My name is Alifimran bin Nazaruddin. I would like to present about the introduction for this project. In this study, we were tasked with conducting a detailed design for two construction components, which is slab and beam, using an architectural drawing. The architectural design chosen must include a two-story structure. We choose to design a two-story building in Tropicana High, Kajang, Selangor, because of its distinct and elegant design. We recognize that its two-story design will make structural component design difficult, but we see it as a future learning opportunity. We only design slab and beam structure, which include both simply and continuous beam. The design module was developed with the goal of providing young civil engineers with a better understanding of how to design reinforced concrete structure using the European Committee for Standardization's new Eurocode (EC). The Department of Standard Malaysia has adopted the standard as Malaysian Standards (MS). Malaysian standards are as follows: first, Eurocode basis of structural design; second one, Eurocode 1 actions on structure; the third one, Eurocode 2 design of concrete structure. Thank you.
Hi, my name is Anambra Isel Anajens, CF200232, and I will present about the layout plan for our project. Okay, for this project, we have chosen an architectural plan for double story house. As you can see there, we provide three architectural plan, namely front elevation, ground floor plan, and first floor plan. And then we proceed by proposing a structural plan for the beams and columns to be analyzed, which consists of ground floor plan, first floor plan, and roof plan. And we have also labeled where the beams and columns are positioned based on the architectural plan, as well as complete with the dimensional sketch for each plan. Based on the structural plan, we have selected several beams to be analyzed for the simply supported beam, which are namely beam A slash 4 to 5, B slash 1 to 3, 5 slash C to D, 2 slash C to D, and 1 slash B to C. So all simply supported beam analyzed and calculation for our project are only on the ground floor. And each beam section was divided to each group member. So for my part, I have made calculation and analyzed for beam 5 slash C2D, and all the calculation I have made are by using flange method. Okay, now for the continuous beam, we have also selected some beam to be analyzed, namely beam B slash 1 to 4, 3 slash B to D, 5 slash B to D is for on the first floor. Meanwhile, for beam 4 slash B to D and beam C slash 1 to 3 is on roof plan. So for my part, I have analyzed for beam C slash 1 to 3, and all calculations are also using the flange method.
Hello, my name is Siti Aisyah binti Hashim. I'm going to explain about analysis of action. Objective of design is to examine the action that will take place in facility. Second, permanent and variable action. Permanent and variable action is to accurately estimate the design load that will be placed on a building that has distinctive tornadoes, spatial dynamic or hydrodynamic load. It may be essential to collect data or conduct an investigation that is site-specific, case-specific, or both. Third, design assumption. First, it is presumed that the slab is simply supported on all four edges, with the corners being able to lift up independently. Second, beams are assumed to be continuous over the internal support and frame the column at the end of the structure. Third, in certain design, the beam is expected to be simply supported and its length is considered to be the same as the slab. Despite the fact that the beam is the drawing is shorter, This assumption is made despite the fact that the slab is longer. Beam size. The beam size that we use is the width of beam, which is BW, is 300 mm. The height of flange, which is HF, is 150 mm. The height of beam, which is H, is 500 mm. The width of flange, which is B1 equal to B2, is 1250 mm. Specification and parameters. Slab thickness is 100 mm. Concrete unit weight is 25 kN per meter cube. Unit weight of brickwork is 2.5 kN per meter square. The characteristic of action. Finishes is 1.5 kN meter square. Variable action is 4.0 kN meter square. The concrete characteristic strength as known as FCK is 25 Newton millimeter square. Steel's characteristic strength is known as FYK equal to 500 Newton millimeter square. Nominal concrete cover is 30 millimeter. We also assume that first bar is 25 millimeter, second bar is 12 millimeter, and bar length is 6 millimeter.
Assalamualaikum, my name is Muhammad Mu'min bin Zulkarnain and my number metric is CF200131. For designing simply supported beam, I designed the beam 2CD. For the beam size, depth is 150 mm and width is 350 mm and effective flange width is 825 mm. For loading, characteristic permanent load is 14 kN per meter. Characteristic variable load is 5.6 kN per meter and total design load is 27.35 kN per meter. For main reinforcement, I use 2H12 for the reinforcement beam, and for beam link spacing is H6300. For designing continuous beam, I design beam 3BD. The beam size is depth 250 mm, width is 600 mm, and effective flange width is 1625 mm for span BC, and for span CD is 1500. For loading, GK is 39 kN per meter, QK is 21 kN per meter, and total design load is 85 kN per meter. For beam reinforcement, for span BC is 3H12 and span CD is 3H10. For the link spacing is H6 400 for both span.
And for summary, after finishing this group project, it helped us understand how structural engineers work. Every step from planning to designing is essential to ensuring that there are no problem or barrier in the building step brought on by failure in other steps. Our group was able to produce architecture drawing for at least a two-story structure, after which we suggested a structural layout plan for each floor, including the roof. In addition, our group identified the qualities of the materials employed, as well as the permanent and sustainable action that would be used to deliver the structure. We learn how important it is to perform accurate beam calculation in order to ensure that the structure is in excellent working order and prevent structural problem like bending and cracking.